An expense reporting architecture in Java remote method invocation. Now you can see an expense reporting architecture in server defined policy. This figure shows the general picture of such a dynamically configurable expense reporting system. Client displays a GUI graphical user interface to a user who fills the fields of the expense report. Clients communicate with the server using RMI. Server stores the expense reports in a database using JDBC, the relational database package. So far, this may look like any multi-tier system, but there's an important difference. RMI can download behavior. Suppose that the company policies about expense reports change. For example, today the company requires receipts only for expense over $20. Tomorrow the company decide this is too lenient. It wants receipt for everything except for meals that cost less than $20. Without the ability to download the behavior, you have the following alternatives when designing your system for change. Install the policy with the client. When the policy changes, this requires updating all clients that contain the policy. You could reduce the problems by installing a client on a handful server machines and requesting all users to run the client from those servers. This would not completely solve the problem. Anyone who leaves the program up and running for days would not be updated, and there are always some people who copy the software to a local disk for efficiency. Point 2, next point, you could have policy checked by the server when each entry is added to the expense report. This would result a lot of traffic between client and server, clogging network and burning the server. This would make a system more fragile. A network failure would hold people in their tracks instead of only affecting them when they actually submit an expense report or start a new one. It would also mean that adding an entry would be slow, since it would require a round trip across the network to the burdened server. Next point is, you could have a policy checked by the server when report is submitted. This lets the user create a lot of bad entries which must then be reported in a batch instead of catching the first error immediately, giving the user a chance to stop making the error. Users need immediate feedback on errors to avoid wasted time. With RMI, you can have the client upload behavior from the server with a simple method invocation, providing a flexible way to offload computation from server to clients while providing users with faster feedback. When a user is ready to write up a new expense report, the clients ask the server for an object that embodies the current policies for expense report as expressed via a policy interface written in Java. The object can implement the policy in any way. If this is the first time that client's RMI runtime has seen this particular implementation of policy, RMI will ask server for a copy of the implementation. Should the implementation change tomorrow, a new kind of policy object will be returned to the client, and the RMI runtime will then ask for that new implementation. This means that the policy is always dynamic. You can change the policy by simply writing a new implementation of general policy interface. installing it on the server and configuring server to return object of this new type. From that point on, any new expense report will be checked against the new policy by every client. It is better. This is a better approach than any static approach, because all clients do not need to be halted and updated with new software. Software is updated on the fly as needed. Server is not burdened with entry checking that can be done locally. Next point, allow dynamic constraint, because object implements, not just data, are passed between client and server. Next point, lets user know immediately about errors. Here you can see a server interacts with clients via RMI. When clients interacts with server via RMI, server interacts with expense record via JDBC here. Now this is the end of my presentation. Thank you very much for watching it.